So good day everyone. I am Jimson G. Kusog of BSEC 3A. For today, for the midterm project, I will be discussing one of the topics in communication for lecture. So the topic that I use is the impedance matching. So what is impedance matching? It is the matching of the source in order to deliver a maximum power to the load through a transmission line. So in many cases, it is not possible to choose all impedance such that the overall match condition result. So this situation requires the matching networks to be used in order to eliminate a reflector. So we have here the matching network of a characteristic impedance and the load impedance. So in general, matching networks are constructed with reactive components only so that no loss is added to the overall network. For the impedance matching techniques, so first we have here a quarter wave transform. The lamp element network. So there are three types of lamp element networks. So we have here the L network, the pi network, and the T network. And also stub matching techniques. So there are four types. The first one is the open shunt stub. The next is open series stub. The third is short shunt stub, and the fourth is the short series stub. And lastly, the double stub or double stub. So we have here the two types, the shunt series and the short open. So lamp network, it is a circuit composed of a combination of capacitors and inductors. So each component is called a lamp element. So the total circuit impedance is composed of the reactance X and the susceptance B. So this is the example of lamp network wherein we have here the reactance is in series with a parallel susceptance and the load impedance, while the next figure is the susceptance is parallel to the reactance and the load impedance. There are three types of configuration in lamp network. So first we have here the L networks. As you can see, the inductor is parallel to the capacitor, while this another one is the capacitor parallel to the inductor. So it forms letter L. Or the second one is the pi network, wherein the circuit form pi. And lastly, the T network, wherein all components is form T. For the L network, we have or to solve a L network, we have here two cases. For case 1, we have here the reactance is parallel or in series with the susceptance and the load impedance, while in case 2, the susceptance is in parallel to the reactance and the load impedance. For the case 1, so we consider the RL is greater than 0. So our configuration will look like this. And for the formula for the case 1, in getting the susceptance and the reactance, so we have here the susceptance B is equals to XL, positive negative square root of RL over ZO times the square root of the RL's and plus XL squared minus ZO times RL all over RL squared plus XL squared. So this one is the formula for the susceptance. For the reactance, X is equals to B, which is the susceptance times the output impedance or the characteristic impedance ZO times the RL minus XL all over 1 minus B times XL. For the case 2, we consider RL is less than 0. So this is the configuration for the case 2 L network. This one is a circuit for the case 2. And for the formula used for the susceptance, we have here the susceptance B is equals to positive negative 1 over ZO square root of ZO minus RL all over RL. For the reactance, X, so X is equals to positive negative square root of RL times ZO minus RL minus VXL. So this is the formula for the case 2 in order to get the susceptance and the reactance. So after getting the susceptance or the reactance, we consider that the sign of the susceptance and reactance. So positive X implies an inductor, while negative X implies capacitor. For the positive B implies the capacitor and negative B implies a inductor. So by getting the capacitor of in positive susceptance, we must divide this both sides by omega in order to get the capacitor for the positive susceptance. There are 4 possible configurations in L network. So for the case 1, we have here if the susceptance and the reactance is both positive. So the configuration in L network for the case 1 is inductor is series to the capacitor and the load impedance. So this one. And for the case 2, assuming that B or the susceptance and reactance is positive, the L network configuration will be capacitor is parallel to the inductor and the load impedance. So this is the same true as in negative susceptance and the reactance. So the configuration in L network, we have here the capacitor is parallel or in series with the inductance and the load capacitance, load impedance. Then in case 2, the inductor is parallel to the capacitor and the load impedance. So we have here a example problem. So design all possible matching L network to match a 55 ohms to a load impedance of ZL is equals to 70 plus J 100 ohms at a frequency of 500 megahertz. So by solving this matching L networks, we have here our given characteristic impedance which is 55 ohms, and also the load impedance is equal to 70 plus J1 100 ohms, and we have here the RL which is 70 ohms and the XL is equals to 100 ohms and the frequency of 500 megahertz. So solution, since the RL is greater than in ZO, so the RL is 70 and the characteristic impedance or the ZO is 55. So we use the case 1 in order to get the susceptance B and reactance. So the formula is for the case 1. So susceptance B is equals to XL positive negative square root of RL over ZO times the RL squared plus XL squared minus ZO times RL all over RL squared plus XL squared. For the reactance is equals to B times ZO times RL minus XL all over 1 minus B times XL. And by substituting the values, we get the two solutions for B1, which is 0.01467 0.01467 Siemens is the SI unit, and also we have another susceptance, a negative 0.01247 Siemens. And by getting the reactance, we substitute the susceptance 1 and 2 in order to get the reactance 1 and reactance 2, which is the 93.1780 1703 ohms in reactance 1, while in the reactance 2 is the negative of the 93.1780 1703 ohms. So after getting the susceptance and reactance, B group is in pair. So we have here our solution 1, B1 and X1, and for the solution 2 we have here B2 and X2. So this is not a final answer for getting the capacitor and the inductor. So for the solution 1, we have here given of susceptance 1, which is 0.0146748,346 Siemens, and the reactance 1 is equals to 93.1703 ohms. So by getting the capacitor of the circuit, we have here the susceptance B1 is divided to the 2 pi times the 500 megahertz, which is the omega. So for the resulting capacitor, we have here 4.67 picofarad. So this is now our final answer for the components in L network. So for the inductor, we have here the reactance is divided by the omega, or the 2 pi times 500 megahertz, resulted to the 29.66 nanohenry. So this is the final answer for the inductor. For the configuration, we have here characteristic impedance, and in order to match to the load impedance, which is 70 plus J100 ohms, we use the inductor, which is 29.66 nanohenry, and in series to the capacitor of 4.67 picofarad and the ZL. So the capacitor is parallel to the load impedance ZL and in series to the 29.66 nanohenry in order to match in characteristic impedance of 55 ohms. So this is the in configuration number 1 of the L network. For the solution 2, we have here the susceptance 2, or the B2, and the reactance 2. So by substituting and getting the inductor, so we have here the inductor is equals to the negative 1 over the omega times the susceptance 2, or the B2. So the final answer of the inductor is 255.12 nanohenry. So this one is the final value for the component of the inductor. While for the reactance 2 given, and by getting the capacitor is equals to negative 1 over omega times the x2, not the b2. So it is equals to 1 minus negative 1 or all over 2 pi times the frequency of 500 megahertz, and the reactance 2, which is negative 93.1780,1703 ohms. So which gives us the value of the capacitor 3.42 picofarad. So this is the configuration 2 of the L network, wherein the 55 ohms is matched in the 70 plus J100 ohms in the load impedance. So in order to match these two, we have here a capacitor is series with the inductor and the load impedance. So we have here the value of the capacitor of 3.42 picofarad and the value of the inductor, which is 255.12 nanofarad. So this is the configuration of the L network. So that's all for my discussion about the impedance network. So thank you for listening and good day.